Now let me test the audio.
Hello, we are live.
Yeah, it's working. Let me put some music. Should work only on Twitch.
On Twitch.
Okay, does not work.
Okay, does not work.
Let me add my Twitch to the description. And we are ready, it seems. Also, let me test the chat I added. Test. And test. Well, my Twitch chat is working. Not the YouTube one. It's a bit annoying. It's echoing? Yeah, sorry, because I'm hearing the stream. Oh, but I can see the chat of YouTube and this. Audio track is 1, this is 2. Browser is working. And then audio properties. Oh, oops. I did it the other way around. Okay, so now it should be working on Twitch, but not on YouTube. Okay, I don't know. I'll just keep it like this. Whatever. Windowed projection. Okay. So, hello everyone. Today we'll be we'll be adding phong shading. Any progress since last stream? Yeah, I fixed the projection that was bugged, finally. And it works fine, textures work fine. I also did some optimizations and now we have like triple FPS. I made a tweet about it. Wait. Here it is. We went from 63 to 276 FPS by adding this little line that makes the for loop parallel. Also, I could answer that. Those eyes, yeah, I didn't add the eyes. Actually, let's add them. Resources. Eye inner. Wait. Freaking, I hate this name. I need to change it. Yeah, so you have the eye inner, and that's it. That's it, no? I freaking had eye inner. Yeah. Do you already know some linear algebra, or are you learning as you go? I do know some, but also learning as I go. Head, eyes, and then just head. Okay. I believe I can add the same head eyes, the same matrix, yeah, the same model matrix, but we're gonna see. And then, I mean, we need this. I'm gonna divide it in two. This would be head, eyes, texture. Still really bad naming, but it's fine. Actually, I wonder what happens if I give it that model. Oh yeah, look, I have the same model inside of the eyes. I wonder how it looks like. Okay, can't really see it really well, but you can see the head inside. Hey buddy, I love your videos. Thank you, thank you, thank you. Eyes texture. Okay, there we go. They do look a bit weird though. It's normal. Okay. So we're gonna keep it like this for now. I thought this was going to be useful. I don't enjoy it. There you go. I'm gonna put both chats side by side so I can read instead. Bro took something. Yeah, definitely. I mean, that texture doesn't fit. Okay. Bom dia. Hello. No Portuguese on the chat. I speak some, but I don't understand it very well. And also most people don't speak it here, so only English. That's the only rule. I want to learn C++ too, but I don't know where to start. I always got stuck in tutorial hell and advice, so can I actually learn it? The way I learned C++, actually C++ was my first low-level language. I just used cpp learn. Yeah, this one. You just follow these classes until you feel like you have some good knowledge. I wouldn't do all of them because most of them are pretty useless STD stuff. And then get onto some project. You can do the OpenGL project, like the learn OpenGL thing, or whatever else. Because then you get stuck in tutorial hell. It's a good morning, yeah. It doesn't necessarily need to be anything to do with graphics programming, but if you want to do graphics programming, then it's a good idea. It's a good project. basically just do projects. That's the best thing you can do. That's how you learn languages plus concepts at the same time. Okay, our main CPP is starting to grow too much. Let us split it into our .gl. Really speaking, it is a binary of the OpenGL library, and main CPP here we can program all we want. Now, what did I put in our GL? Model, view, viewport, projection matrices along with initialization functions, and the triangle raster. That's all. Here's the content of file our GL. So since we can't create classes nor structs, we can have like a context thing for our shader and like pass in the functions or something. And this is cool because it takes the shader as an argument. Thanks for the advice. No worries. Yeah, graphics programming is pretty hard at the start, and you might quit the first time you start it. So I wouldn't recommend it as the first thing to learn C++, but if that's what you want to do at the end of the day, then just do it. It's not like it is incredibly hard. And then main CPP becomes this. Right. Takes iFace and birth. Written by the vertex shader, read by the fragment shader. Yeah, so we like give information to each. I don't know what virtual means. C++ is my first programming language. If it is your first programming language, then yeah, I don't know. You can think about it, but I don't know if I would recommend it. Started with Vulkan in graphics programming, so fourth rewrite of the project. I am no beginner. Yeah, I mean that's what happens when you start with like graphics programming and no experience. You usually end up rewriting many times because you're not happy with the abstractions that you made. And in Vulkan you can like do validations and whatever, so there's plenty of room to rewrite. New model. Same thing as before, creates the shader and yeah, that's it. Then delete the model. But I can't go into OpenGL. I know too much what's working underneath, and OpenGL is too much abstraction for me. Yeah, understandable. Wait a second, I'm responding to something on Discord. Let's see how it works. Skipping the headers, we declare few global constants, screen dimensions, camera position, etc. I will explain the garage shader struct in the next paragraph, so let us skip it. Then it is the actual main function, parsing the obj file, initialization of the model. I mean, I get that. The last step is the most interesting. Outer loop iterates through all the triangles. Inner loop iterates through all the vertices of the current triangle and calls a vertex shader for each vertex. So yeah, this is the interesting part. We have screen chords. We're doing it a bit different, but not that different. Screen chords 3, this would be clip. Then for each screen chord, they call the vertex shader with I and J. Right, so this would be the face, and this would be the A, B, and C. And then at the end, with all the calculations or whatever we did, we pass in screen chords to the triangle and the shader. And I'm guessing triangle executes the fragment shader. Makes sense. Though what is confusing is we return false if we do not discard this pixel. Right, and you pass in the color of the pixel itself. And bar, I'm guessing, is X, Y, and Z. Alright. Yeah, the main goal of a vertex shader is to transform the coordinates of the vertices. The secondary goal is to prepare data for the fragment shader. Right. So we can do all the matrix multiplication on the vertex shader, and then when we pass into the fragment shader, we can do whatever else. What happens after that? We call the rasterization routine. What happens inside of the rasterizer, we don't know. Well, okay, we do know since we programmed it, yeah. With one exception. We know that the rasterizer calls our routine for each pixel, so our fragment shader, namely the fragment shader. Again, for each pixel inside the triangle, the rasterizer calls our own callback, the fragment shader. Okay, how many times are we gonna repeat fragment shader? The main goal of the fragment shader is to determine the color of the current pixel. Secondary goal, we can discard the current pixel by returning true. The rendering pipeline for OpenGL2 can be represented as follows. In fact, it is more or less the same for newer versions too. Vertex data, primitive processing, vertex shader, primitive assembly, rasterizer. Oh, interesting. I wonder what primitive processing is. The rasterizing, we wrote it ourselves. Then fragment shader, depth and stencil, color buffer, blend, dither, frame buffer. Too many fragment shaders. Yeah, too many. If I grab on this page how many times they mention fragment shader. It will overflow the amount. Because the time limits I have for this course, I restrict myself to OpenGL2 pipeline and therefore to fragment and vertex shaders only. A geometry shader would be interesting. Okay, in the above image, all these stages we can touch are shown in blue, whereas our callbacks are shown in orange. In fact, our main function is the primitive processing routine. Oh, right, it calls the vertex shader. We do not have primitive assembly here since we are drawing dumb triangles only. In our code, it is merged with the primitive processing. Triangle function is the rasterizer, right? For each point inside the triangle, it calls the fragment shader. It then performs depth checks, z-buffer, and such. This is all. You know what the shaders are now, and you can create your own shaders. Do you think it's better to start with a software rasterizer? No. I mean, I think you should start with learn OpenGL, then rasterizer, and then if you want, you can go to Vulkan or something like that, since you now understand the pipeline because you wrote it yourself. OpenGL is good if you have somewhat good understanding of language. Yep. Hell, I mean, you can write your own software rasterizer with compute shaders if you want to do everything in OpenGL. My implementation of shaders shown on Gurat shading. Let's check the shader listed above in the main CPP. According to its name, it's Gurat shader. Let me relist the code. Bearing intensity written by the shader, read by your fragment shader. This is nth bird and face. Right. But compute shaders run on GPU, not CPU, and are not. Yeah, of course. That's the thing. Like, if you write everything in compute shaders, it's much faster. But I feel like it's a bit harder to debug. Parallel, yeah, you got it. STD max. Oh, model normal. Oh, right. But where do I get the model from? Am I passing that? Oh, I guess it has to be global, but then the abstraction doesn't really work. GL vertex, model bird, eye face, and birth. Viewport, projection, model view, GL vertex. Which in our case would be MVP, this, and all of this, and all of this, and no, that's it. Is it? BU mat, model mat, perfect, yeah. And then this passes bar. And that's it. Is it really a software render then if it is on the GPU? You know, I'm not sure about the definition exactly. I feel like if you do the rasterizing on the CPU, then it's software rasterizer and then hardware rasterizer. I think it's also software rasterizer if you write the rasterization on the GPU yourself, right? But then it's hardware rasterizer when you use GL draw arrays, because it's implemented by the driver. I think it's like that, but I'm not sure. Hey bro, what's your first programming language? My first programming language was Python and then JavaScript. This written is called for each pixel. Inside the triangle we draw as an input, it receives very centric coordinates. Oh. Interpolated intensity can be computed as, or simply as a dot product between two vectors varying intensity multiplied by bar. In true GLSL, of course, fragment shaders receive ready interpolated values. Notice that the shader returns a bool value. It is easy to understand what it does if we look inside of the rasterizer. Discard, and then that. Although it can be slower than built-in. Yep. I mean, I think the journal did a benchmark of compute shaders versus like the OpenGL pipeline, and compute shaders were faster because you didn't have to go through the pipeline, I guess. But also, of course, he was using OpenGL. I don't know if it would be much different in Vulkan. For an eye cool. Okay, let's see. Right. Oops. Of course, the rasterizer cannot imagine all the weird stuff you could program, therefore it cannot be precompiled with your shader. Here we use abstract class iShader as an intermediate between the two. Well, it is quite rare. I use abstract classes, but without it we would suffer here. Pointers to functions are ugly. Yeah. That's the bad thing, since I'm writing it on C. So here they do intensity, varying intensity multiplied by bar. Intensity is higher than 85, then 1, blah blah blah. Simple modification of the grid shading, where the intensities are allowed to have 6 values only. Oh, interesting. So it becomes like the shadows are way more noticeable since you only have 6 colors. SD texture mapping, all done by SDL. What would be texture mapping? Like I just use SDL for loading the image, right? Then I use barycentric coordinates to calculate which pixel of the texture it is. I'll skip the phong shading, but take a look at the article. Yeah, I mean, I'll implement that based on this. Remember the homework assignment I gave you about we had to interpolate UB coordinates, so I create 2x3 matrix, 2 rows for U and B, 3 columns, 1 per vertex. Right, I need the UE for knowing which side is the texture facing? Bearing UV. I think I won't do this. Here's the result. Okay, now we have texture coordinates. What can we store in texture images? In fact, almost anything. It can be color, directions, temperature, and so on. Let us load this texture. If we interpret RGB values as X, Y, Z directions, this image gives us normal vectors for each pixel. Not only as before. By the way, compare this image to the another one. It gives exactly the same information, but in another frame. Coordinate system. Another one is Darbox frame, so-called tangent space. In Darbox frame, the Z vector is normal to the object X, principal curvature, direction, and Y, their cross product. Exercise. Can you tell me which image is represented in? Can you tell the representation is better? And if yes, why is that? Uniform? I'm not adding uniforms. It allows you to pass constant to the shaders here. Pass. It's inverse transpose to transform the normal vectors referred to the end of lesson 5. So computation of the lighting intensity is the same as before, with one exception. Instead of interpolating normal vectors, we retrieve the information from the normal mapping texture. Do not forget to transform light vector and normal vectors. So you pass from this to having this. Why? What do you mean? Specular mapping. Okay, let us continue the fun. All the computer graphic science is the art to cheat. To cheaply trick the AI, we use the phong approximation of the lighting model. Phong proposed to consider final lighting as a weighted sum of 3 light intensities: ambient, diffuse, and specular. By uniforms, they're using this as the projection and model view, so they don't have to calculate it each time, I'm guessing. And then uniform MIT is projection, model view, invert transpose. But I don't think I'm even gonna implement the shader abstraction thing they're doing. Doesn't seem very useful. I'll just add it to the rasterizer to keep it simple. I compute diffuse lighting as a cosine of the angle between the normal vector and the light direction vector. I mean, this supposes that the light is reflected in all directions uniformly. What happens to glossy surfaces? In the limit case mirror, the pixel is illuminated if and only if we can see the light source reflected to this pixel. No, you said I'm not adding uniforms. Yeah, I mean, I was planning on doing the shader abstraction, but I'm just not. I'm not adding uniforms. I'm not adding the shader abstraction. So. Or maybe I am with like shader context or something, but I don't know. It's just like you always have bearing parameters, so it's like it makes no sense because you have to edit it every time you want to create new shaders. And I would have to do it with function pointers since I'm using C, I'm guessing. Yeah, so this is some simple vector math, and then you check if there's a light source based on the UV. For diffuse lighting, we computed the cosine of angle between vector n and I, and now we are interested in the cosine of angle between vectors. Directed light direction and view direction. Given vectors n and I, find vector r. If n and I are normalized, then r is equal to n. Okay, then what happens if we take 10th power of cosine? Recall that all numbers inferior to 1 will decrease when we apply the power. It means that 10th power of the cosine will give smaller radius of the reflected beam and 100th power much smaller than beam radius. This power is stored in the special texture that tells for each point if it is glossy or not. Yeah. So we would need to pass the texture of the model plus the diffuse. Wait, no, the specular mapping texture. And based on that, you know how much it reflects. I took 5 of the ambient components, 1 of the diffuse component, and 0.6 of the specular component. What coefficients to choose is your choice. Different choices give different appearances for the object. Normally it is the artists to decide. But it's not that normally the sum of coefficients must be equal to 1, but you know, I like to create light. We know how to render quite nice scenes, but our lighting is far from being real. In the next chapters I will talk about shadows. Alright, let's implement this. So, I guess I will give it a try. Shader.c. So, normal frac pass and frac color. It's interesting because we get frac color as an input. In here. Cannot rename symbol? There's no symbol at a given location. What is happening to my LSP? I'm thinking, can I do color result dot r plus equals 1? Like then it would have to look more reddish. Maybe that's not enough. Not enough still. It's probably gonna overflow it somewhere. No, it didn't. Okay. Yeah, we can add the lighting there. So how is it exactly? Yeah, so we need the normal. I'll remove the eyes for now. And apart from the texture model, we need the norm model. I can't get BERT norm model. It's not even this. You give it the face index, norm model, and result, and it's a BEC3. Okay. I guess I'll name it like this. Or AN. Yeah. Now I'm guessing I have to normalize. Yeah, and it goes from -1 to 1, I'm guessing. Yeah. I mean, I just add it like this. It's starting to look a bit messy. AN CN. Right. This would be 0 and this would be 2. And then where we have normalized texture, we normalize normal normalize UV or BN, and it takes in just the destination. Right. Screen width and screen height. Also, so how would this go? I think I have to do this, do this, and I'm sure this is gonna be the other way around vertically. Yeah, probably. But we're gonna see. Okay. And then we normalize BN with BN. So messy. And then back to AN, BN, CN, and it's actually back 3. Now this is for the model matrix, so it's fine. This model view projection, so I don't need to do any extra calculations. Actually, to keep it simple, I could just do this, right? Yeah, this would be A. B. C. Lebowski. That's me. Okay. So you have A plus, you have A normal. You pass the A normal to the fragment shader. Oh, it's also passing the light position. Interesting. Projection, view, model. And then it normalizes the light direction, light pulse minus frag pulse. So ambient strength multiplied by light color. Right. Here we are assuming it's white, I'm guessing. Oops. Where's the implementation? Here. Well, they are doing it without the texture, so how does it look at, like with the... Okay, I'm gonna go bye. See ya. Intensity is model normal multiplied by light direction. And light direction is this. Okay, I'm gonna keep it simple. I'm gonna add it to the top. And probably like that. Okay. Eye center up, yeah, that's like we had. So all we do is multiply the normal by light direction, though the interesting thing is they are not normalizing it. Yeah, they're not. Then GL vertex is model BERT, read the vertex from OBJ file. Right, and that's it. Variant intensity multiplied by bar. The color multiplied by intensity, and that's it. Okay, interesting. So, first of all, let's ignore all of this. And this would be 255, 255, 255, and 255. And add to white. I'm gonna leave that there. Then after that, we need to multiply it by intensity bar, which we get it from here. What font are you using? I'm using Comic Mono. This, it's free. So for now, let's not normalize it then. I still think we need to do the same thing for the height, but I'm gonna see. So we need intensity, which can be a, what is it, Back 3F. They multiplied bearing intensity by bar. Okay. Back 3 intensity or bearing intensity. And it's supposed to be these. Oh, because it's doing it per phase. So I have to do it 3 times. I'm guessing. Then I have to do it against the barycentric chords. So it would be AN 0 multiplied by alpha. Yeah, BN 0 multiplied by beta. CN multiplied by gamma. And then I have to do this here. How do you increment this? GA, I forgot. Oh, whatever. Oops. So these are the intensities. And it's this multiplied by the light direction. Oh my bad, so this is just intensity. Wait. This is just intensity based on the barycentric coordinates. And then we need to calculate the bearing intensity, which is again 3 times bearing intensity. What? And this would be oh wait, no, I'm dumb. Right, because I mean I can't compare it to this because they're doing other stuff. They normalize the normal, light pulse minus frag pulse, and then they start calculating already the diffuse. I just want phong shading. Let me think about it. So they get the max between this, right? And then they get the intensity based on the normal and the light direction. This is based on end birth. Okay. This would be varying intensity. So per each of this, we need basically I don't get it, because light direction is this, so they multiply it by 1, I guess. So let's imagine this is AN, then it's multiplied by light there x, right? AN 0 multiplied by light there 0. Is that it? And then this is BN, light there 0, and then CN, light there 0. And then it would be the same thing for each. I think that's it. I could make this simpler and just multiply it by back 3, but I'll keep it like that and I'll refactor it later. So then out of that, I need to get the max, right? So 0. I'm not sure if I can do this with the macro. Oh, it does work, okay. Oh, so annoying. Okay. And then after that, I think we just need to do bearing intensity A. Is that, yeah, bearing intensity multiplied by bar. So now I don't get, how do they get a float out of bearing intensity multiplied by bar if they are both Mech 3s? This is the thing about C++, like you don't know what is going on ever. Yeah. Okay. This makes you feel so stupid. Oh, I'm doing, like, what am I doing? Okay, I think that's it. Or is it? Okay, this makes no sense. I feel like it would be like this. And then you would just go B, C. I'm completely guessing the math. But it makes sense. And then I'm guessing after doing all of that, then I do A multiplied by B. No, A plus B plus C and divided O. Yeah. And I'm wondering, to make it easier, what if I create Vec3 bar chords, and this takes alpha, beta, gamma, and instead of doing all of this, I do GLM Vec3 mol. So you have mol, and it gives the destination to this, and then you have mol B, which I wonder, what does it do? deprecate it. Okay. So it's just GLM back 3 mole. Bar chords. And then bearing intensity A. That would be it. And of course we would give intensity A as the result. And then you just do the same for this, and this, this, and this. Like that. Then you would F32 intensity multiplier, and it's just okay. I don't know what back 3 mole. I don't know what functions we have. Add. Add S. Add scalar? Nope. Add sub? Add two vectors and sub result to dest? No. Mix, that could be it. From to, no, that's not either. I think we have to add both. Yeah, no other way. Add intensity A, intensity V. We can name it back 3 intensity result. Then we do again the same thing. Intensity result with C. And then at the end, this is intensity result 0 plus intensity result 1 plus intensity result 2 divided by 3. And then finally we do color result dot R multiplied equal this GB. Wait, there's no way I got it right the first time. Well, I don't know if it kind of looks right. It doesn't look too bad. It should be coming from the right. And it's getting the back like this. So the thing is, he has the coordinates in a weird way. So what happens if I R0 here? Okay, right. 05. Okay. I don't think that's it. And 2. Okay. No, it's definitely that. I think we need to normalize this. How would it be? Yeah, because this returns get vert norm model. You give the index and it just returns the vertex normals. Yeah, so since it's back 3, I don't know how would I normalize it. Pretty weird. You can definitely see it more here. I feel like it's correct, like directly. Because what do we do with the vertices? We just multiply them by MVP, so... I feel like we don't have to. Then I don't get why my shadows are looking different. Also, it would be cool if I could change the angle of X on render event poll here. So this changes angle. Yeah, I would need like the same thing for down and up. The monitor's turning off. Okay. And then instead of having here angle, we will have angle Y, angle X. Yeah. And then we're doing it by angle each time, but we are not converting X. So I think it's that. Move right, left, and... Oh, what? I didn't save this? Up, down, right? Yeah. Oh. Right, that's fine. Okay, good. He's looking at like this. I feel like, okay, when I look at it, it's like the intensity is a bit higher on his. And also... Oh, I forgot this is Gurat, not Phong. So it's supposed to look like this, like a bit blocky. Right? And then here they do varying intensity multiplied by bar. If intensity is higher than this, then do 1, blah, blah, blah. Let's try doing this and see if it changes, how it looks. Let's comment that out so the result is similar. This intensity mole. Okay. Why is that intensity mole? Why not intensity? Yeah. Okay, let's see, and let's multiply it by. So they're doing 255, 155. And 0. Right? Yep. Okay, so now we can see the difference better. The light is definitely coming from the side that we want it to come from, right? I feel like I'm getting some little math incorrect, which makes it look right. Because look, here, does it change if I move the... Nope. I think I know what it is. What happens if I move it down a little bit? Model matrix, yeah, GLM translate model matrix, and let's move it down back 3. Zero Fs, 1 0 F. 0 F. Wait, this is gonna go down incrementally, right? I think it is. Oh no, it's not. Okay, so let's go 0.5. Oh, it's the other way around. It doesn't go down incrementally because it's 0 in it. 0.3. Okay, and then render angle X should be by default, I don't know, 45. That's the other way. Isn't it? Wait, what am I doing wrong? Maybe it's O. Okay. Y, we don't need it. No, I need Y, I don't need X. Hey there, Vince Dev. You were on my Discord, right? I think, yeah. I can recognize your name. And you were Brazilian, I think. So it's like this. A bit down. Oh, it is the other problem. I need the coordinates of each of these. That's why it's not changing, because it's completely dependent on the normal. So this doesn't change anything. So definitely something in my math is incorrect. Though it's a bit annoying that maybe 35 and make this 0.0. Three. And maybe in the x direction 0.2 minus this. A little too much. 0.5. Nice face, yeah. Very, very good. Wait, doesn't that point to the right? What? Oh. I'm a bit stupid. Okay, there we go. There I can kind of visualize it. So I think it's never getting too higher than 85, right? Like what happens if I do higher than 75? Oh, that's it. What? Higher than 65? I think the problem is that we're displaying colors. Okay, so that's the maximum value? Seems to be. Like, I remove this and I just do higher than 40 to make sure. Oh, no, never mind. Yeah, so my supposition is correct. It's not getting to the intensity that it should be, right? Wait. Alright, let's just keep this commented and check until where does it get. The highest intensity should be at the top right. So at 60 it isn't. At 50. Yeah, it is at 50. Interesting. And it has this little thing. Alright, so we're definitely doing something wrong. I wonder if it is this division by 3. And then just keep it at 85. Now this is definitely gonna make it brighter, right? Yeah. What if we divide it by 2? This wouldn't make sense, right? But okay, we get some weird stuff. It's definitely divided by 3. Oh. My bad. Okay, if we divide it by 2, it's gonna get in there. And if it is by 1.5, of course I'm not gonna hard code it like this. I'm just checking that. Okay, that's too much. Yeah, that's pretty much it. Around there. And then the left side is completely black. Yeah, so this is init white. Wait. Okay, so here it's overflowing, right? Because we're only doing by this amount. So we gotta cap it in there. Or we can just make sure that no. Wait, let me check. If you do 255, it gives you 0. Right, so it doesn't limit it. So we can just do a max, I guess. Like this value, 255 OF, this value. Oops. There we go. My bad. Then, like whoever is smaller. What? Oh, right. Because this. So we would have to do it there. Okay, let's just ignore this. Anyways, it like would just fix the issue without properly doing it how it should be done. So keep it at there. Yeah. So we're definitely doing something very wrong here. This is 85. Okay. So let's check our math again. This is our math. For someone on Windows, you sure know how to move any of them. Kinda jealous. That's kinda like an insult and like a compliment at the same time. I'm still improving. I have cold hands at the moment, so not doing the best. But after some warm up, I start doing way faster edits. Yeah, both. Okay, so we do max this, this and this. So it grabs bearing intensity, d-vertice, so A, B, or C, I'm guessing. Or, wait, never mind. I hate, you know, the only thing I hate about Windows is the way you move around Windows. Like, I don't want to press Windows tab. I want to just Alt tab, but that's so annoying because like you change some little tab and then you have a different order and whatever. I forgot how it's called in Linux, but you can have like different shortcuts like for each Windows and like different layouts. I think there was an option to do that on Windows with a program, forgot the name. That would be the only reason why I would switch over, for that little ergonomic thing. So it grabs normal and birth. So in here we grab the normal model, give it the face, triangle count, yeah, so this is the face, and this is the end birth, right? So ABC, and here we're passing end birth as well. In our case, we have I face and end birth multiplied by light year. I think I have to do AN1 and AN2 here. And like same for all of those. Yeah, that's annoying. I'm pretty sure if Windows was open source it would be a blast. I mean, I think Windows shouldn't be open source, but like some parts of it should be. Right? So like for handling Windows and like other stuff, since it's like proprietary and of course like you have to pay to use it, or that's the purpose, that it's a commercial operating system, then it wouldn't work for it to be open source, but some parts could be open source, so it's easier to mod. Kind of like JetBrains IDEs, like, you know, they make some parts open source, so it's easier to add plugins. Like if the plugin system in Windows would be simpler, that would be so good. Maybe at some point they do it. So this is AN1 right there and AN2 and this. Right, and here we just change this to BN. My bad, also need to see. Okay. I feel like that could be it. Okay, I am not. So the interesting thing is here it's completely black, so it means like it is kind of working, but then not really. Also, I don't get why this like thing happens. I think I was doing the calculation right before. Can I do this? No, I don't format it. Okay, so this was correct. They could like make a version of it open source. The commercial version could have their daily garbage, and the free one the rest. Yeah, I mean, they wouldn't do that, right? Because I think they gain the most out of Windows by adding telemetry. Because like no one buys it, everyone pirates it, except in corporate environments. Like they have to pay for the license, of course. So I don't know. Maybe they could be a little less greedy. We'll see what happens with Windows 12 or 14 or whatever they decide to launch. This... Okay, I'm gonna imagine it like this, because X, Y, Z, right? Then here you give it X, here you give it Y, and here you give it Z. So pretty much this would be BA, I mean AN, yeah. BN, CN multiplied by light direction, right? And then for each also it is like I'm saying, I think, because here AN is a back 3, right? Of course light deer is also a back 3. So you would be multiplying both and making sure this 2 are max. std max in C, mine is just a macro. Yeah, I think that would be it. So it's AN multiplied by light deer, and then std max 0, like that. That's the part that makes no sense to me, right? Because model normal, light deer, yes, returns a back 3, and then model normal is gonna return a back 3, right? And then bearing intensity is a back 3, so it should be like I said. But then when I do it like that, when I do it like that, it's giving those weird artifacts. I think it's because I'm doing the barycentric coordinate multiplication wrong, right? Because you get bearing intensity, this, multiplied by bar. Interpolate intensity for the current pixel, right? Bar is a back 3, bearing intensity is a back 3 also. So we need to interpolate. Is there something like that? Okay. And wait, interp. Is it lerp or smooth? Have you tried Sig? Barely. Not too much. I did try Odin though, and I really liked it. I'm not a fan of the syntax of Zig, but I think it's not fair to hate on it for the syntax. Oh, here it says for interpolation of bearing data. Thus, interpolated intensity can be computed as bearing intensity 0 multiplied by bar 0 plus this plus this. As a dot product between two vectors. Cross product. Let's see. So instead of having this, I'm getting a call. Okay. Do you like it? I don't know. What's so amusing about Odin? It's basically like Go, but no garbage collection. And I'm all in for simplicity, so I like it. Also, vendor packages, no build system, and yeah. Okay. The thing is, it grabs bearing intensity 0 multiplied by bar. Yeah, so that's what they're saying. Dot product, what am I doing? Dot A and B. And where's the result? Oh, Okay. I'm guessing I can just do so many comments. I can just do this. Okay, no. Okay, I think that's it. Okay, sort of. AN1, AN2, light deer 2, and then BN1, BN2, light deer 2, CN1, CN2. I'm not sure how to debug it. Because it's like it works for all the pixels, but then for some it does this on the edges. So I'm not sure how to debug it. And then if I do it on white directly, I'm guessing it's gonna be the same, yeah. And how about right? How about if it is intensity A, B, and C, right? Wait, first of all, let's check if I divide this by 3, right? So no, all right. Then we do this, and then intensity A, B, and C. It's probably not that. Definitely not that. But it ain't this either. So before I was doing the calculation like this. Wait. Before I was doing bearing intensity 0 multiplied by bar 0. What I do is bar coordinates multiplied by it. Yeah. Then I would add all of them. And that would be it. Okay, so I'm not sure why doing it by dot does not work, because it's pretty much the same thing, no? What does dot do? It multiplies A, B, C. And then adds them. Don't know. The thing is, he's not doing the multiplication by 3, right? Went to take a look at Odin. Is really a chat version of Go, but still seems just okay. You could say that. Like, if you don't like the simplicity of Go, then you won't be amused by Odin, right? I use C because of its simplicity and it being low level, and like you can do pretty much whatever. And you kind of know what your code is going to be equal to in assembly, more or less. And with Odin, you kind of lose a bit of that, but it's still very simple and you can kind of know the assembly anyways. And it has a lot of game dev stuff incorporated, so you already have matrix multiplications. Do you? Yeah, Matt for Mo and Odin. They don't add operator overloading, so you have the multiplications like built in, and I think they do SIMD like directly, so it's pretty cool. And same with back multiplication and division and whatever. And then you have vendor packages for the most used game dev stuff, like Glue or Raylib or whatever. I don't know if they do SDL. Anyways, I wanted to I32 iterations. And then iterations plus if iterations is equal to 10. Let's do this afterwards. Then abort. Oh. Yeah, I mean, that makes sense because I'm not dividing by 3. Okay. I'm not sure where it's starting. I think it's starting like around the back. We could do 100 iterations and look what happens. Okay, at some point it reaches 2. Which should be impossible. I like Sec because you understand what's going on in your code, you know what you typed and how they work. It's teaching me a lot about memory management. Odin and Go seem a little too simple for me. Yeah, I mean it depends on the level of complexity you want. Like if you're okay with meta programming in Zig and not knowing sometimes what is going under the hood, it's alright. I mean, I like that it's explicit in terms of like memory management, but I wouldn't use most of the features because I just use arenas, right? So I allocate at the start of the program and that's it. And if I need more memory, then I allocate a bit more. So it doesn't fix anything for me. And then error management is cool, but I'm already doing something like Go. Yeah, I have like an error to string, and like I do this. For example, here you have file delete, and you return file delete error, and it tells you like which type of file it is, and then file delete error. Sorry, and then you have a warn unused. So if you're not using the result that it returns back, it warns you. So you just do if does not equal 0, which would be the same, like if error does not equal 0, or you can just do success, or file delete success, whatever, then you whatever. So it's pretty much the same thing. What are you trying to do right now? I'm adding phong shading to my engine. Okay, so when I divide by 3, there are some places where it reaches the threshold, this 1.3, 1.5, 1.5. Yeah. So I should probably max it at 1.f, right? What? It's doing 2 here. Is my max function not working? I think I need to... this seems like some bug with macros. Some intensity. BT... wait. BT this. Some intensity. That could be it. Okay, there we go. And I should be min, my bad. Alright. So now if I do that, and we go back to what we were using before, it was this. I mean, the thing is, here we were reaching that, no? Kinda. What? I don't know graphics programming, so yeah. Oh, Funk's shading is this. Basically, you have a light source and you calculate the lighting depending on each pixel and the lighting direction and the UV. Okay, now I don't know where I'm going wrong. It was working before with this. And now it doesn't. By the way, I'm gonna try... Where's it coming from? CGLM. Yeah. So here I should probably struct.h. Can I just do that? Yeah. Okay, so what happens if I just do vector yes? And what is this? I'm getting lost. Struct.h CGLM. So GLMS. I'm guessing there's a way to... Oh, because it just takes vector S, okay. Yeah, then never mind. Look at that like it is. Wait a second, I'm gonna open the window. Or maybe just get the fan going. Okay. Got the fan working. Let me see if it is hearable on the stream though. I think it isn't. If you can hear it, tell me. I can add a new suppression, I guess. This is the same. Maybe so screen A, screen B and screen C are normalized with viewport, and NDC is basically what screen A was before. Okay, for the 10th time, let's see. And birth in this case would be A, B, or C. Phase is the phase that we are on. So you can imagine it's just 0. And then unbirth again, A, B, or C. Multiplied by light direction. So we have A, normal, which would be multiplied by A normal 1, A normal 2, and light deer. Now the first thing is it should be at least 0. Yeah. And then it is n multiplied by light deer. Is there something like GLM back 3 max? Max is equal to B0. If B1 is higher than max, then max is B1. If B2 is higher, oh no, it gets the max value of the vector. Max. No, there's nothing like that, I guess. But what about if that's what they are doing? Right, so then we would have, yeah, we would have this GLM back 3 mole, and it would be AN multiplied by light deer, and obviously we store it here, and then we would need to do GLM back 3 max, and then we give it that, and this returns a float. No, that's definitely not it. Okay. At least I made sure. Okay, so if that's not it, then AN, BN, BN, CN, CN. At least 0, max, whatever this multiplication is. And I'm guessing this can go overboard. Okay, so this is correct. And then here we do bearing intensity. So any of this. Yeah. Multiplied by bar. So this multiplied by bar. Which is bearing intensity 0. This multiplied by bar coordinate 0. And the same thing for this again, 1 and 2. And then it stores the result on A. Intensity A. We do all of that. And then we multiply intensity by this. Since we are doing it for the 3, right, this is the part where I'm not sure. Because we calculate A, B, and C intensity, and then we grab the result and sum it up. But I feel like it's what we're supposed to do. Bearing intensity 0. The thing is, they're calculating it so weirdly. Like they call it each pixel, but then just this is the bearing intensity. I'm not getting it. Oh, it's because they're doing cross on here too. Right. Hey, how's it going? I'm also into graphics programming. I've been working on a robotic arm kinetics simulation in OpenGL and Java. Do you currently work in the software industry? First of all, cool project. And no, I don't work in the software industry. I'm still learning. Probably not prepared to work yet. So the thing is, it should be deck 3 bearing intensity, and bearing intensity 0 should be this plus this, and that, I think. Are you trying to break into graphics programming? Yeah, I am. In the meantime, I'm doing YouTube, but ideally I would at some point get something, some type of job related to graphics programming. I don't know how possible it is, but I feel like if I try hard enough, it might be possible. Yeah, so then I do bar chords by bearing intensity. Intensity result. Yeah, same for me. I've been working on my project in hopes to leverage it to at least get an interview for graphics precision. Yeah, that's what I'm hoping for too. I'm still missing a lot of knowledge, so I don't think I would get an interview. So I'm just continuing on until at some point maybe I get something. But my location is not helping, since I'm from Argentina and most companies that do graphics programming are in the US. So bearing intensity is 0. Yeah, we first do all the multiplications and then we sum them all up pretty much, and that should be it. Okay. Well, it's close enough. At least now I get it. So this is init yellow and this is white. Right? Then we do the multiplication and sum it all up. Yeah, I don't know. I guess I can try doing like instead of all of this. Oh, it's because I'm dividing it by 3 also. It's supposed to be summed. Oh! Okay, I think I got it. What? Oh, because this is not white. Yeah, there we go. I mean, the intensity is very high, but that's it. How about we just multiply it by intensity and okay. So it's kind of like that, but I'm overflowing somewhere. So that's pretty good. What do y'all do in graphics programming in a production context, of course? So as far as I'm aware, it's a lot of maintaining multiple backends in game engine or render. So as a graphics programming, you have to maintain Vulkan code or add Vulkan functionality and OpenGL for old systems, I guess. And same with DirectX. C decompilador. Hello. How's it going? By the way, I think I should make the Streamlabs alert box a bit. Not the alert box, but the chat box, yeah. Each message should last. Always show message, yeah, I could save it like that. I just sent a small video of my application in your Discord. Let me check it. I have my Discord open. Let's see. Okay, yeah. You're getting there. Okay, let's try to do the math like I was planning. Yeah, that's nice. So here I should be grabbing bearing intensity multiplied by alpha, and that, yeah, beta, gamma, bearing intensity again, and bearing intensity. Wait, do you use Comic Sans? You're like me, people called me crazy, but I'm not alone. Yeah, I mean, it's not Comic Sans, it's Comic Mono. I love this font. But there's a lot of people that love this font. I always get comments on my video saying like, what is that font? I want to use it. And they end up realizing that it's Comic Sans. Meanwhile, they didn't know before that. CPU rendering, that's my thing. Is it parallel? Yeah, somewhat. I mean, this is the only thing that is parallel, but right now I'm commenting it to make sure I don't get any weird bug. By the way, is the chat thing working? Oh yeah, cool. Does it work with YouTube? Let me see. Yeah, sort of. Oh yeah. Okay. Yeah, I'll keep it like that. Because it disappears and then I can't read it. So it is supposed to be varying intensity multiplied by bar 0, so alpha, varying intensity 1 multiplied by beta, and varying intensity multiplied by bar 2, so gamma. And then sum them all up and you get the intensity. The thing is, it's reaching like peak intensity all the time. Iterations is higher than 10 aboard. Or let's just do 100 and iterations plus plus. Yeah, it's definitely going overboard. I wonder why. Is it because the light is too close? Like, I think it shouldn't have any effect, but maybe. No, it shouldn't, because I'm not taking into consideration where the model is at, right? Or do I? Like, if I change this to -5. Iterations plus plus. Right. Keep that. Yeah, so I moved it down and it didn't do anything. About 1. Yeah, it's still the same intensity, so I guess that changes nothing. Let's try normalizing, because in OpenGL they do normalize, but rather than this, so this is spec 3, and like it should all be well except this. And then for this, we can do this. I'm not sure if that changes anything. I enabled it, okay. Okay. No, definitely not. But at least I can keep it in mind. I'll just keep the function there. So before it was too... Yeah, before it was too dark, now it's too bright. Then you have a good YouTube channel? Yeah, I just started on Twitch, so... this is my first stream on Twitch. But on YouTube I'm getting more viewers than in here, since it's competing with the algorithm or whatever. Do you make an OBJ importer for your application? Yeah. Look at it. Look at this beauty. It's 59 lines of code. Oh, never mind. It's 72 lines of code. I mean, plus getting the vertex model, texture model, and normals. I'm gonna turn off the fan. It's like I'm so close, but so far away. One night I had to as well, yeah. For my OpenGL renderer, I didn't. I just used, what was the name of it? I forgot. It's the most used one. In bearing barrels, we store data to be interpolated inside the triangle, and the fragment shaders get interpolated value for the current pixel. Like, it calculates end birth per each. But it makes no sense. And then just to make sure, GLM cross this. What is the difference? It's just a convenient wrapper. Alright. AB. Oh. Yeah, it's this minus this, but no, that's not it. And dot. Oh, this is it. Yeah. PLM back 3 dot. Bar chords and bearing intensity. Yeah, looks the same. By the way, what happens if I dot 80 here, 60 here, 40, 30, 20? I mean, how about we just else F that's 85 and then 95 is 1. Yeah, I don't know. Whatever. After getting the cross product, they don't STD max, right? Yeah. Oh. Right, now I see this. I need CT. I'm just gonna keep this as reference. I like hitting my head against the wall trying to make this work. So it should be again this. But instead we need to use BN and light there, so AN. B, C. And then here we just get DMX, like this. Alright, I think that's it. Hallelujah. There we go. So it's not the same. But the method's the same, which is good enough for me. I'm unsure why it's not the same. Let's see. 85 is 1. Yeah, it's about the same thing. And then they multiply all of this by intensity. And I'm guessing they leave that the alpha value untouched. Okay. Now, how does it change here? What? Okay, so the only thing that we are dealing now with is overflow. I think once I get that, it's gonna look good. Maybe. And here I have to make sure like instead of color U8, let's do color. Wait, do I use this anywhere else? Get pixel. Oh, then maybe let's create another one. Color F32. Yeah. Wait, F32? Yeah, F32. You wait. Color F32. And then when you create color, you have all these U8 values. Okay, let's see if that changes anything first of all. No. Okay, so create color. Let's create color F32. And then like, oh, I can't, right? So keep the calculations in F32, and then when we're sending them here, make sure the max is 255. We can do that, I guess. BT, comma, comma. RGB. Okay, there we go. Yeah, I mean, kinda still having that artifact, so I'm not sure. Have you thought about making your own Vulkan? I don't understand much of the GPU architecture, so probably not yet. I haven't even used Vulkan, so I'm still missing that. Also, I'm not sure how would you do it. Like, I would have to look into the implementation that they did for the. They were reverse engineering macOS to run Linux, and they had to implement their own Vulkan. I think it shouldn't be that hard. But I'm not sure, like, how do you work with these drivers? Not possible with RE, possible, but not easy job. Yeah, that's what I'm saying. Like, you would have to reverse engineer drivers. So I'm guessing it's possible if like you use open source drivers like from AMD, but I would need to have an AMD GPU and then just look into the Linux kernel how they implement that. I don't know. You poke the PCI until you see colors. Yeah. I mean, I forgot what was the name of their project for the reverse engineering of macOS, but that must like be really interesting how they implement the shaders themselves. The shaders, the GPU drivers. I'm not sure how accessible it is to read. By the way, now that I'm seeing it, yeah, under the eye it's getting the shadow, but not on here. And the intensity is like at the highest from here on. No, from here on. How about if I minus one? Okay, I mean, it is working. It just feels like intensity is too high. Like we do this for each of vec3, right? 0, 1, 2, x, y, z. Once that's done, we model normal vec3, dot it with this, depending on the normal that you're given. And then you mux and check what it is. Then they embed the GL vertex, whatever. they read varying intensity, which is varying intensity multiplied by bar, alpha, beta, gamma, bar coordinates, bar chords multiplied by varying intensity. Like, does it matter if I multiply in this order? I feel like it doesn't. No. And then they graph and they multiply 255 by intensity, RGV, right? Before doing that, I grab the min and I get this. Which in their case is darker. I'm not sure if they're limiting it to some value. Because like, if I were to divide this by minus 0.1, like what happens? Right, it overflows. God damn it. Like, I think it also doesn't work like this. Oh no, it does. So if I do it by 1, no. Nope. Okay, that's kind of like that. Okay, now it's too much, no? Yeah, but here it's like grayish. What if I divide? So kind of like that. Okay, that's around that. Like it would be something like 75 or 85. Okay, and what happens if I then I enable this? I hate this managing of windows. Okay, but pretty much the same. Like I guess it would be 90. I guess it's easier to realize like this because it should follow the same pattern. Okay, so this made it smaller, right? It's like 80, 90. It's like 87. also literally. Oh, never mind. Needs to be like a circle. 75 could be. Okay, that's it. Okay, that's exactly it now. Yeah. I don't know how they get to the same result without doing that. I think under the hood they are doing something to TGA color, but I'm not gonna look into this. I mean, I would just leave a comment. Wait, can I just... Oh, never mind. Great to have Mod who teaches as well as we go, yeah. I mean, not really. If you were since the end, since the start of the stream, maybe you learned something, but it's hard to learn with a project like this as a watcher. Something like that. Okay, I'll remove this. I'll get this to white, or rather I'll remove the... Damn it. I removed getting the colors for this. I can just check on GitHub, CPU render. Just go to the latest commit. Let's see. Yeah, this should be it. Also, this doesn't seem to change anything. The definition of color. Right. There we go. That looks correct. So we basically grab the coordinates and then multiply the intensity by that, and you get different shadows, or like how black it is. Actually, if I add the eyes, I wonder eye texture. Yeah, I wonder if it adds the shadow as well. I think yeah. Okay, good. I definitely have to change this to the struct API. I'm wondering if there's like a namespace is configurable. We can omit GLM's namespace or even change it to a custom namespace by move existing API integrations to CGLM more easily. We can also add S to the function. Okay, but how do you do it? Ah, you add this. So CGLM omit NS from struct API omits this. Default is not defined. Define namespace default CGLM. And then this is I could now just use this. I'll just leave it as a comment on here. Also, can I CGLM slash, because it doesn't look pretty. CGLM struct.h, yeah, that's oops. Include. Right, it's because I'm including like this directly, I think. Vendor CGLM. Is struct in here? No. Then struct.h. Ah, it is. Yeah, that's why. Okay, I guess we can move this instead of CGLM to do I don't know, that's fine. Because basically this is instead of CGLM, but since we're importing this directly, it doesn't really matter. This render, let's see, render.h, yeah. Okay, remove that. Define. Move everything to struct.h API. And of course remove namespace. And then this becomes CGLM underscore becomes that. Okay. By the way, why don't I import it in there directly, right? Okay. Anyways, this should be pretty simple. I might do it at evening. I'll just do a stream implementing struct.h. Yeah. So how are we on time? 3 hours. Okay, let me. I'm gonna turn on the fan again. So now we have texture coordinates. What can we store in the texture images? In fact, almost anything. It can be color, directions, temperature, and so on. Let us load this image. If we interpret RGB values as x, y, z directions, this image gives us normal vectors for each pixel of our render and not only per vertex as before. By the way, compare this image to another one. It gives exactly the same information but in another frame. Alright, I feel this is easier to parse. One of the images gives normal vectors in global Cartesian coordinates, another in Darboux frame, so-called tangent space. Oh, I see. I prefer the Cartesian coordinates. This is 0 to 1, right? No, minus 1 to 1, I'm guessing. In Darboux frame, the z vector is normal to object x. Wait. In Darboux frame, the z vector is normal to object in x principal curvature direction, y their cross product. So Darboux frame is this, and global coordinate frame is this. Can you tell which representation is better, and if yes, why is that? I mean, this seems to have more information. This seems to have less, right? That's all I know. No, they do bearing UV, which is set call nth bird model UV. Right, so like we were doing before, by the nth bird. But what is set call? I'm guessing, okay. So this is 3 columns. Right, and they do this, and then this is the same as before. All the matrix multiplication, bearing UV multiplied by bar. Interpolate UV for the current pixel. And to this, they add N and L. Get the intensity, diffuse, and by that you get this thing. Hi, nice to see you live. Hey, nice to have you in the live stream. Uniform is a reserved keyword in GLSL. It allows you to pass constants to the shader. Here I pass the matrix projection model view and its inverse transpose to transform the normal vectors. Oh. Yeah, I wonder how can I get the invert transpose. So computation of the lighting intensity is the same as before with one exception. Instead of interpolating normal vectors, we retrieve the information from the normal mapping texture. Do not forget to transform light vector and normal vectors. Where is it passing it? Bearing UV. Oh, because they do model diffuse multiplied by intensity. Right. Right. Let me see. Do we need? Yeah. So this is to calculate the specular. All right. And they do that. I feel like, okay, now, oops, I need two things. Fix projection bug, done. Lock textures on begin drawing, unlock on end drawing, move to CGLM. But before of that, implement shader abstraction. Oh, actually, I already have that. Yeah. We'll do it in this order. Alright. Well, that's enough for today. I'll end the stream. Thanks for everyone that turned up. And I'll see you guys later. Might stream in a bit later. Or I might just stream tomorrow. I'll try to finish fixing the bug, but I might do it off stream. So, yeah. See you guys.